Welcome to the overview of our module on the Hyperledger ecosystem. Hyperledger is an umbrella project hosted by the Linux Foundation, one which BME is an academic associate member of. Hyperledger is an open source business blockchain toolkit. It supports building your own blockchain infrastructure, but it's also available as a leasable offering on most cloud platforms. By blockchain standards, Hyperledger is a very mature project. For instance, Hyperledger Fabric is well into its 1.x line by now. The significance of Hyperledger as a project and as a community is that, on the one hand, it contains one of the leading consortial platform solutions. It has an unbeatably wide ecosystem, and by today, it's the base of numerous successful consortial blockchain offerings. The Hyperledger ecosystem contains a large number of projects. Our module focuses on a select subset of these. A planned later course aims at introducing the remainder. We base our discussion on Hyperledger Fabric, a leading permissioned consortial blockchain platform. Hyperledger Bureau supports running Solidity language smart contracts on Hyperledger Fabric, essentially creating a layer of interoperability between Ethereum and Hyperledger. Hyperledger Grid, an upcoming project, aims at providing supply chain support for Hyperledger platforms. Hyperledger Composer is a solution that enables rapid prototyping of blockchain applications. Uniquely, it has a close-to-business domain-specific language. Hyperledger Caliper supports performance measurement and performance analysis, two activities that are key to the capacity planning of Hyperledger deployments. And last but not least, Hyperledger Quilt provides an implementation of the standardized interledger protocol. Hyperledger Fabric connects so-called consortia of organizations using a technological platform. It supports a wide range of consortial trust models and almost all blockchain application patterns. Uniquely, its performance is designable. Potentially, it scales to thousands of transactions per second. It also has a rather sophisticated security model. On the one hand, there's the possibility of introducing private transactions where the specifics are maintained, stored only by the interested parties, and the common ledger stores only checksums of the performed transactions. Classic authentication and authorization is supported by the platform. However, there's also the possibility of introducing anonymous client authentication. And thirdly, in an upcoming release, Hyperledger Fabric will be able to support privacy-preserving transfers of assets that are, while on the one hand they are privacy-preserving, also capable to support audits of transactions. Hyperledger Fabric is also present on all major cloud offerings, essentially meaning that if you don't want to create your own Fabric infrastructure, you can simply lease an almost turnkey blockchain solution. Our module discusses the key capabilities of Hyperledger Fabric, beginning with a high-level understanding of its consensus approach, going through topics as its resource use model and transaction privacy capabilities, and also touching on performance and scalability concerns. We also match these capabilities to typical stakeholder concerns and discuss how Hyperledger Fabric can address these concerns. To summarize, the key messages of the module are the following. Consortial blockchain deployments have to be designed and can be designed. We discuss how the technology influences this design process. As Fabric is the emerging leader in business blockchain applications, we use it as an example during this discussion. We also provide an analysis of the application scope of Hyperledger Fabric and fit it to application categories through specific examples. The role and the importance of an integrated technology stack and open source ecosystem is also discussed. This is a property that is unique to Hyperledger at the moment.